All right, let's go ahead and talk through 799. So Jamal was working on his homework when he had a realization. He was drawing a triangle in a unit circle to estimate the sine of pi over 10 when he realized that this triangle is the same kind of triangle that he draws when he wants to find the slope of a line. How could you express the slope of the radius in terms of the sine and cosine? Okay, so what you have on this picture is actually the angle pi over 10. So this angle right here, this rotation, is pi over 10, just to be clear, okay? So what we have here are two sides of this triangle that we can label then. Let me go ahead and put pi over 10 inside the triangle so we don't forget. So this is pi over 10 as an angle of rotation. Now, when I look at the two sides of this right triangle, I know that the side that's adjacent to it is going to just be the cosine of pi over 10. And I know that the side that is opposite of it will be the sine of pi over 10. All right, so we know that based on our relationships that we've been studying. So how could I express the slope of the radius? Now here's the radius, okay, and we're looking at the slope triangle here. So remember, slope means rise over run. So our slope triangle ends up being the sine of pi over 10 over the cosine of pi over 10. All right, now that's an interesting little result here, but what could we do here to try to represent the slope in another way? So let's take a step back to geometry for a minute, and instead of labeling things as cosine and sine, what if we think about, here we have, let's just call this angle theta, just as a generic way of measuring it for a minute. We have this right triangle, okay, and we know the radius. We actually even know the radius is just 1, but that's a little bit more than we need to at the moment. What I really want to talk about is if this was just a right triangle, right, we would label this as the opposite side, and we would label this one as the adjacent side, right? Because this is our hypotenuse. So in our right triangle, if we look at these two sides, we have a trig function that puts those two sides together. That trig function would be tangent. So what I really want to think about here is that we could write that the tangent, and I'm just going to use theta, is just the opposite side over the adjacent side, which in our triangles, we know that the opposite side we're calling sine. So this is really the same thing as saying sine of theta over the cosine of theta. So we can write our slope triangle as sine over cosine, but we could also write sine over cosine as tangent. So those are going to be equivalents to each other, and that's really what we wanted you to get from this.